Okay, welcome to, what is today? Wednesday. It is the 20th of March, right? I'm doing well. Okay, guys. Welcome to your ENVM 605 weekly dose. Are we excited you all showed back up after the test? That's a good thing. So we got a couple of things this module we're going to cover. Noise toxicology. So what do you guys think about noise? So here's what we're going to also do at break. We're going to grab some of the meters and going to kind of play with those a little bit too. So we'll do some monitoring. The online guys, sorry you have to get your own meter and do it. But yeah, we'll show them a few anyway. So when I say noise hazard, what do you guys think about? Professors talking?
Annoying sounds and noises interfering with warning signals and communication between them.
Yeah. So here's what I want you to think about. Is this a noise hazard? You put somebody in personal protective equipment and the noise reduction rating, you may not know what that is now, but the noise reduction rating is so high that they can't hear anything. Is that a noise hazard? Because you're protecting them against the equipment, correct?
Depends on the situation.
Okay, what could be the different situation?
Let's say you're in a machinery space where you're taking readings on specific pieces of equipment, and you have to use double or even double hearing protection, which blocks out almost all noise because the diesel engine is like 145 decibels.
Mm-hmm.
But you still have to take those readings. So your hearing is more important than actually being able to hear while you're in the space. But if you're in a situation that requires interaction with other people, then you have to be able to hear them.
Okay, what about interaction? You just hit that one. What if I'm in a warehouse? By the way, you guys keep in mind, he just said something that I always, what's the level? What would be the level of 145 decibels? Is that even feasible? We'll take that bet. Okay, good. So here's the thing. Let's say you are protected. Let's say you have a noise reading around 110 decibels. You have in a noise reduction rating. Let's say earplugs that take you down 30 decibels. You can't even hear normal conversation. You're in a warehouse and there are forklifts running around. What's important with a forklift? And noise. You guys are thinking, I know you're thinking, why would you worry about noise and forklifts?
That's why you don't walk in the place that's taped off yellow.
Oh, but what if the forklift and the pedestrian have to share a path? What have you just done when you put them in the noise? You've created a noise hazard. You've gone the other way. We always think of noise hazards as being loud. Sometimes as IHs, we create it the other way. And I want you guys to understand, sometimes our protective measures create more hazards, okay? So I just wanted to go through that. So we're going to talk about noise hazard. You guys, it's kind of the readings you'll do. We'll talk about amplification. You'll talk about the sound wave. But here's your basic, I always say this, what is noise? If you had to describe it, what is it? You guys said unwanted sound, but how does the ear hear noise? What is it?
Vibration sends off a wave, and the vibrations are picked up through your ear.
Okay. Vibration, send off a wave, and the wave picks it up in the ear. So what do you pick up in the ear?
A wavelength.
A wavelength, okay. So what if I do this, guys? Well, watch what I'm doing here, hands-wise. What did I just create? Noise. How did I do that? If I do it again so they can see it, what did I just do?
You moved air with your hands.
I moved it with my hands. There you go. Dave's hitting it. What did I create?
A wave.
I actually created pressure. By the way, that is what noise is. It's pressure. So never forget that. That's actually what activates, and we'll talk a little bit more about that. Here's a basic fundamental equation. You'll never see us doing this, but the speed of sound, wavelength, and then frequency. And Dave, that's what you were talking a lot about. The loudness, the height of the wave, I always say, is the loudness, the intensity. The sound pressure, I've already talked about it, because we're going to do some equations throughout this that talks about pressure. And also, here's your important things. You guys know this. Oh, go ahead, yeah. You guys know it. What does sound? Okay, I'm going to use this as an example. How loud am I right now when I'm right here standing at you?
Louder than you.
Yeah, louder than when I back up here. If I don't raise my voice, what does it sound like? Gets quieter. So again, is it a straight distance? And that's what we'll talk about, the square of the distance. Frequency, again, the jackhammer, you guys can talk about it, and wavelengths, we'll talk about two similar patterns. So, range of the ear. Normal, healthy ear. You guys see it there, basically 2,000 hertz to basically 20 to 20,000. So as you look at that range, that's pretty wide, isn't it? It's hard to describe. And remember back to Dave's thing about 145 decibels? What does that have to do with frequency, hertz, and all that? Are the two related? Yeah, and that's what we're going to talk a lot about. How do you take these concepts and make them into something you guys know? And if you look right here, basically we're going to use a log scale. And we're going to use not the natural log, but the power of 10 log, okay? Normal logarithmic scale. So, here's your first equation. I need you guys, if you don't already have a piece of paper out, kind of think about this. You know, pull it up here, and I want you to write down. So what's this equation telling you guys? What's LW? By the way, Dave used it. Yeah. It's a sound pressure level or sound power level. What is log of a W? What is your W? Sound in watts, right? And your LW, which, by the way, is what we usually want, but basically you've got a known standard. So I want you guys to understand this equation. First fundamental noise equation. And, being the kind guy I am, I'm going to give you an example problem. Basically, you're going to determine the decibels for 0.001 watts. How would you do that with the equation I just gave you? So I'm giving you 0.001 watts. I want you guys to calculate it and tell me what the decibel level is. And this is where I can help you. So what did I give you? 0.001 watts. What did I give you? Did I give you LW, W, or WO? There you go. So we know 0.001 is on top. What is WO? The reference, basically. 10 to the minus 12 watts. So if you take 0.001 divided by 10 to the minus 12, what do you get? What'd you get, Dave? You don't have, oh, that's it. You're definitely out of it.
90.
90. So when I take the log of 90, what do I get? Oh, you already got the final answer. Okay, yep. And for those guys, always show up to class basically when you take 0.01 divided by 10 to the 12, and you can do it this way, 10 to the third, minus third, 10 to the minus 12 is a log of 10 to the 9th. Here's a valuable thing to know. What's the log of 10 to the 9th? 9. And then the answer is, ding, 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 90. Yeah, you got ahead of me. Guys, see? Basic fundamental problem that you'll have to work. So again, we talked about pressure. Pressure is proportional, again, to the square of the power. So here's your next equation we're going to talk about. And we're going to define noise, guys. I've got some things we can talk about noise, but in this class, this is kind of when we really kick into the calculations. So your P reference again is 0.00002 newtons per square meter. And you're going to notice I had a heck of a time. I'm like, there's another number that I'll usually use. And here's what I want you guys to see. I gave you another example problem. I won't make you work this. Sound pressure level coming from a source generates 1.7 or 1.57 newtons per square inch or per meter squared. When you plug that all in, what do you come up with? 97 decibels. So again, that's in your notes. You've got the example. Here's what you guys will see me do. I'll talk about micropascals. That's the standard I'll usually use. You'll notice that if you ask me during the study questions, hey, I need some help, probably I'll tell you, okay, what are you using as your reference? I will warn you, hey, I'm using 20 micro. It's just, I always say I'm old school and I kind of like that. That's the way I learn. But the level means a quantity above the reference. So here's something very important. And I'm going to do this where everybody can see this. Guys, I'm going to show you a shortcut before you see the right way to do it. So if I give you a reading, you have 3 machines in a room, and I better be complete. I hope you can see this. Okay, I give you 88. One machine is 88 decibels. One machine is 90 decibels. One machine is 95. What's the level in that room, approximately? Okay, everybody say 95. Do you think he's right? Makes sense, doesn't it? This is what I want you guys to understand. You can't directly add log scale quantities. So you can't add them, or you can't just say the noisiest one. So I want you to use this chart here that's up here. So the difference between the sounds in decibels, 0 to 1, you're going to add 3 to the larger. If it's 1 to 4, you're going to add 2. If it's greater than 4 to 9, guess what? You're going to add 1. And if your difference is over 9, you're going to actually add none. So I want you to do the first one using this. 88 and 90, what's the difference? 2. So what am I going to add to the larger? Yeah, 92 decibels. So I got 2 here, 95 and 92. What's the difference? 3. So what do I add to the larger? So 1 to 3, the difference is 3. I'm actually going to add 2. So the answer is 97 decibels. That's how you use that chart. Now, what you guys did and what I used to do when I first got into the field in my first class, I did exactly what you guys did. I said, well, you had 3 sources. You can't be louder than the loudest source. Guess what? You can, because they're added together. Remember that whole sound pressure properties? That's what you want to remember. So this is a shortcut. In your Stewart book and probably in the problems in a little bit, I'm going to take you through it, but I wanted to show you this shortcut. Now, you guys will look brilliant. If you're ever with an engineer and they're trying to figure out how loud equipment is, if you put it together, remember this formula. They'll be amazed that you can do that. So you guys got that one? That will get you, if you guys go into Starbucks and give them $10 and tell them this trick, you know what you can get? Any coffee in Starbucks. No, you guys aren't laughing. Here's the other example too, and I want you guys to try this one. I'd like for you to write it out. So your levels are 92, 89, and 93. So do those 3. And yes, I'm going to block you can't look at it. No, I'm kidding. Guys, look down. Look down at the paper and try to solve it on your own. So again, the level's 92. 89, 93. And there is an example in your Stewart book on this too. And it's one of the things I tried to show you, and that's the Industrial Occupational Health Calculations book. So how did you work it out? Did you do it like they did? Did you do 89 and 92? What's the difference?
3.
Yep.
I added
3, you added 2, you got 94, right?
the difference between 92 and 94 is 1, so I added 3.
Yep. So there's again what you're doing. So then 93 and 94 1, so the total was 97. Which again, guys, don't feel bad. When I first saw this, I thought, how can it be louder than the loudest one? That's the difference between you and an average environmental safety and health person. You understand sound is pressure, and pressure can be additive. So nice job. Now to Dave's point. What's 100? I told you guys I'd come back because I love people that throw 145 decibels. What would you actually find that high level? And Dave's going to look it up, but I wanted you guys to see kind of the sound pressure levels at different times there. So I wanted you guys to see that. So if you look at it there, you've got everything from when I talk, and I'm a little bit loud, but what level does this say I am when I talk? Normal male voice at 1 meter. 60 decibels. So here's what I'm going to tell you, reality. Normally about 70, most people talk about 70 decibels. So here's a good thing. If you can't hear 70 to 80, I always say, if you can't hear someone in a space and you have to raise your voice, probably means you're near 84 decibels. Another trick of the trade, about 84, 85, where you need hearing protection. So I did give you guys this. I'm not going to spend a lot of time on the anatomy, but you could see some questions down the road where we talk about this. So I always say, if I put it in the slide, at least go through, look at the important parts. In particular, what do you guys think is one of the pivotal parts here? What do you guys think? What actually transfers the noise information to the brain? If you look at this chart, you may be able to see it. See anything on there? Yep, absolutely. Yep, there you go, the cochlear. I actually, and that's what I wanted you guys to study a little bit and think about it. I actually have a niece and a nephew that are totally deaf. It wasn't the the transmission device, it was the cochlear itself. They had to have an input put in to hear. So again, this kind of describes each path. You guys will notice that there's how it ends up going out to the brain. So again, just a good way to look at it. And of course, because I'm interested in the cochlear, kind of a cross section of that with different things on it. I wanted you guys to kind of see that. So, 2 types of hearing. And that's hearing loss, I should say, hearing loss. Conductive. What do you guys think that is? Kind of read what they are there. Now, do you think we actually deal with it in occupational health? Do we deal with usually do you get an infection of the middle ear from occupational health? From your job? Not usually. I figured somebody would bring up something that maybe you did depending on where you're working. Usually, let's hope you don't have trauma to your eardrum. I know occasionally you will, depending on what you're doing. And even more than that, normally ear canal blockage, which again can affect usually wax buildup. This is where you're going to need medical attention, conductive loss. Now, which one do we deal with? The bottom one. sensorial neural loss, we deal with that all the time. What happens? Does it happen immediately? Have you guys ever been to a loud concert where there's lots of music? What do the next day? Can you hear well? Huh?
I wear earplugs.
Wear earplugs, yeah, at the concert. Only you, Dave. I knew you were going to say that.
Well,
You're a bigger nerd than I am. That's it. And I probably shouldn't say it, but I always see there's people with earplugs in, and I have them in too. So I can.
have hearing loss. From
Yeah.
my time in the military, and
Absolutely.
I have not a constant ringing in my ears, but I have ringing in my ears. If loud noises, I'll have ringing in my ears for days afterwards. Because the earplugs were garbage.
Yeah. There you go. Go to the advertisement. But again, and what are you talking about you have when you have that ringing in your ears? Tinnitus. Yeah, absolutely. Dave we set this up earlier today. I told him to talk about it, didn't I, Dave? No, I didn't. No, it's good. You're my straight man. That's it. Can I go to the registrar and refund some of your tuition? No. Yeah, I know. I'm kidding. So again, the other thing that I want you guys to do too, here's your problem with our job. Not only do we get exposed to noise on the job, you get old curmudgeons like me that are losing their hearing just because of the natural aging. So that's where you really need your occupational health person to help. Now let's kind of get about, if you were going to do a reading of noise in this room, how would you plan it? And this should give you guys a hint.
Fewer the places that have more sound.
There you go. So you'd start with a noise meter and do a noise map. Now, why is that valuable? What's that tell you? Yeah, it tells you the levels, the noise throughout this room. What do we care about? What's our job as an industrial hygienist or an EHS professional? What's the number one thing we want to do? Yeah, protect the human beings. Why do I suddenly say these noise dosimeters, why are they important? What's the difference between, I walk around with that sound level meter, I go, okay, over here it's 85 decibels, over here it's 90 decibels. I go around, that's really good, isn't it? I got a good noise map. Will that protect people?
No.
Yeah. You got to know what they're exposed to throughout the day, and that's what the noise dosimeters, and I'll grab a couple at break. We'll pass them out to you guys and let you see a noise dosimeter versus a noise, basically sound level meter versus a noise dosimeter. So here's your kind of your control strategies. You can do area monitoring to identify the sources, and you can even do some frequencies. So guys, we always talk about dBA, you'll hear people talk about dBc. The bottom line, when we speak, it is more the A weighting. And some of the information you'll read this week, we'll talk about the A weighting. But again, what you want to think about is C weighting is usually machinery. So we worry more about A weighting because that affects our hearing. And again, you guys can see there is a B weighting, but very, very seldom used unless you're actually going in and calibrating a sound level booth. So that will look in that. So again, the human ear does not respond to it uniformly, and again, the low frequency. So that's in your notes. Here's the big take-home message from it all. There is one point where on this chart, as you look at it, A, B, and C cross. What is that point? And I want you to tell me in frequency. Where is it?
Like 1,000?
Yeah. So why is that an important point? That is where, just so you go, at 1,000, that is where a lot of occupational hearing, as far as testing, things like that, sound level, will usually occur. If you go in for a noise or basically an audiogram, they will look at that too. And we'll talk a little bit later about what they calibrate. Just so you guys know, we calibrate at a couple of different levels, and you guys will hear this, 94 and 114 decibels. We calibrate equipment at 94 and 114. The reason, if you guys take those numbers and back calculate the pressure, you're going to see the reason is there's 1 Pascal and then 10 pascals. So that's why we look at those as calibrating. Noise control, you guys know this. What is the hierarchy of controls? If you ever, we talked about it last week. What's hierarchy of controls? What's the first thing if we have a problem we want to do?
Identify.
Yeah. You have a noise, a loud noise. You're in charge of the area. What are you going to do with that loud noise? What would you do if you were a great industrial hygienist, and you guys would all be?
Limit access to them.
Okay? Dave says limit, but before you do limit, what would I want to do with that noise source?
Measure.
Okay, so I measured it. Stop it. Absolutely. I'm going to eliminate it. So your hierarchy of controls, no matter what you're doing, you're going to eliminate it. I gave you guys a couple on here. You're going to see that in some of the notes I give you more. But you're going to eliminate it. Now, Dave's thing is we're actually going to eliminate it, or we can substitute something else. Well, for noise, that's very difficult. You're probably not going to be able to do it. Or the next thing we're going to do is engineering controls. What do you guys think for noise engineering controls would be?
Sound absorption panels.
Sound absorption panels. Enclose the noise source.
You know, some way to stop the vibration from leaving the area.
Yeah. There you go, enclose it all, that's it. So if that doesn't work, what are we going to do next? And that was your first idea, Dave. Have somebody come in, leave, come in, leave. So we're going to do an administrative control. Limit the access to the noisy areas. By the way, what's the last thing we're going to do, guys? Personal protective equipment. Where do we all start when we have a noisy area? We put them in earplugs, don't we? That should be the last thing we do. Why do we do that first?
Cheapest.
Easiest. It's not even cheaper. In the long run, it's not as cheap as eliminating. But that's why we do it, and plus that's the reason we were trained. So I need you guys to really understand hierarchy of control. Eliminate, substitute, engineer, administrative, and the last one's PPE. And there's some things in the notes from last week that definitely hits that. So your noise risk factors as you're talking through it, your sound power, it's exactly what you guys said, how loud it is, the frequency, the length of exposure, and these all need to be defined because each of them affect it. So, questions on noise? Okay, I'm going to grab a couple of meters. You guys go on a quick break and we'll be right back.